Picture this. June 6th, 1944. You're a German soldier manning a bunker on the French coast. The invasion fleet is out there somewhere in the grey Channel fog. You're scanning the water for landing craft, for destroyers, for the things you've been trained to watch for. And then you see them. Canvas boats, dozens of them, low in the water, barely visible, strange looking, harmless looking. You hold your fire. Why waste ammunition on oversized rowboats? 30 seconds later, those canvas walls collapse, and 31-ton Sherman tanks open fire on your position. That deception wasn't an accident. It wasn't improvised. It was engineered, tested, and built into 693 tanks across factories on 2 continents. And it hinged on one question that nobody thought had a good answer. How do you get a 70,000-pound armoured vehicle to float? Welcome to World War II Objects, where every object tells a story. Let's go back to August 1942. Allied planners have just watched the Dieppe raid turn into a catastrophe. Churchill tanks beached in the shingle, unable to move. Infantry cut down in the open without armoured support. 3,623 soldiers killed, wounded, or captured in under 10 hours. The lesson was brutal and clear. You couldn't land infantry on a fortified beach without tanks arriving at the same moment. Not after, not minutes later. At the same moment. But tanks couldn't swim. Every engineer knew that. A Sherman weighed over 31 tons. Drop it in water, and it goes straight to the bottom. Unless someone could change the laws of physics. Enter Nicholas Straussler, a Hungarian-born engineer working in Britain who'd been quietly obsessing over amphibious vehicles since 1927. His solution was almost embarrassingly simple in concept, but devilishly difficult in execution. Think of it like the hull of a wooden boat. The wood itself is denser than water. It sinks on its own, but shape it correctly, give it enough enclosed volume, and the whole structure floats because it displaces more water than it weighs. Straussler's insight was this. You don't need to make the tank float. You need to make the tank plus a sealed canvas structure float together. He designed a collapsible waterproof screen, canvas reinforced at the base with a mild steel platform welded directly to the Sherman's hull. 36 vertical rubber tubes, inflated by compressed air bottles, held the screen rigid and upright. When fully erected, that canvas wall rose high enough to trap an enormous volume of air around the tank, displacing enough seawater to keep 69,665 pounds of steel bobbing on the surface. The Army called it the Duplex Drive. Soldiers called it the Donald Duck tank. By early 1943, engineers had adapted it to the Sherman. By February 1944, American factories were producing 15 converted tanks every single day. But here's the question nobody likes to answer. What happened when those tanks hit the water off the coast of Normandy? Here's what most people think they know about the DD tank. They all sank at Omaha Beach. Saving Private Ryan showed them going under in the opening sequence, and that image locked itself into popular memory. But the real story is more complicated and more important. On June 6, 1944, the 741st Tank Battalion launched 29 of their Sherman DDs approximately 5,000 yards offshore in seas that were, by every account, far rougher than anything they'd trained in. Sergeant Paul Reagan watched it happen from his landing craft. His testimony, recorded in July 1945, puts you right on that deck. The ramp went down and the first tank went off. I watched it clear the ramp and turned my head to start giving instructions to the other ones. And at that time, there was a big explosion near our craft, and all the tanks were pushed against each other and tore the screens. I saw that the only tank that went off the LCT had sunk. The water was very rough. 27 of those 29 tanks sank. Crews drowned inside steel hulls in water so cold and rough that escape was nearly impossible. But here's what the same documentary record shows. 3 miles away, the 743rd Tank Battalion made a different call. Their naval commander, Lieutenant Dean Rockwell, is recognised the seas were too dangerous. He kept the tanks on the landing craft and drove them directly onto the beach. All 32 arrived. The 743rd fought across Omaha all day, losing only 9 tanks to enemy fire, not to the Channel. Think of it like 2 surgeons given the same emergency protocol, the same training, the same patient, and reaching completely opposite decisions in the operating room. One decision cost 27 tanks and their crews before a single shot was fired at the enemy. The other saved them. Now here's the detail that should change how you think about this entire disaster. A naval order, Raid M. Hall's Operation Order. BB-44, dated May 20th, 1944, explicitly stated that in adverse sea conditions, DD tanks should be landed with the first wave instead of launched. Historian Charles Herrick's 2025 analysis confirmed the 741st Tank Battalion was never on the distribution list for that order. They launched into those waves without ever knowing a backup plan existed. The canvas didn't fail, the engineering didn't fail, the communication chain failed. Here's what makes the DD tank story genuinely remarkable. On 3 other beaches that same morning, it worked almost exactly as designed. On Gold, Juno, and Sword beaches, British and Canadian DD tanks launched in calmer conditions and reached shore before the infantry. When those canvas walls collapsed on the waterline, German defenders suddenly found themselves facing a 75mm gun at point-blank range with no warning. One surviving crew account from the 4th 7th Royal Dragoon Guards describes how the tank looked afloat, transformed into an innocent canvas boat with no hint of the lethal weapon beneath. That was the operational genius. The screen didn't just keep the tank floating, it disguised it. German shore batteries were trained to target steel warships and armoured landing craft, not clusters of drifting canvas. It bought those crews the seconds they needed to close the distance. The tanks then crossed the Rhine in March 1945 during Operation Plunder. They crossed the Elbe in April. Each time, the same 36 rubber tubes, the same compressed air, the same canvas, doing exactly what Straussler calculated it would do. By the end of the war, 693 Sherman DDs had been built in Britain alone. The US was producing them at peak rates of 15 per day. The concept proved so sound that British engineers tested flotation screens on the Centurion tank in the 1950s, and early versions of the American M2 Bradley still used the same Straussler screen principle into the 1980s, 40 years after those first canvas walls rose on a tank at Brent Reservoir in 1941. That canvas-sided shape sitting in museums today, at Bovington, at the Tank Museum, at Ahmednagar, it's the only surviving Sherman DD with its original screen intact. When you look at it, you're not looking at a tank with a boat bolted on. You're looking at a deception weapon, a 31-ton illusion built from canvas, rubber and compressed air. You're looking at the gap between a backup plan that existed and the men who never received it. And you're looking at proof that the most dangerous weapon isn't always made of steel. Sometimes it's made of canvas. Thank you for watching WW2 Objects. If you have suggestions for other WW2 items we should cover, from individual soldier equipment to battlefield engineering to naval technology, leave them in the comments below and we'll give you a shout out. Don't forget to like, subscribe and hit the bell so you never miss a story from the battlefield.